Hello everyone. So in this video we will be studying about Facade pattern. So we will see what is the definition of the Facade pattern, how to draw its UML diagram, its implementation using the Typescript, and some interview questions. So let's see what is the Facade pattern. So before showing you the definition, let me tell you this is also a kind of wrapper only. Till now we have seen the structured design patterns that act as a wrapper for different interfaces to make them compatible or to make them work for code reusability and maintainability. So this is also one of those, but yeah, this is not so similar to previous design patterns. So see, this pattern also acts like a wrapper. When you have some workflows that need to be orchestrated in a specific manner, such as calling one service and then the other under certain criteria, it is quite tricky to bring the logic across your components every time. With this pattern, you hide all those complexities behind an API and offer a simpler, more readable way to call those workflows. In simple terms, you can use a function to wrap many service calls together so that the client will call it with fewer parameters. Alright, so first let us understand what this actually says, and then I will give you an analogy as well so that you can better understand. Let's say that there are two different classes and then you want to use both of them. There will be a function that will use both of them. So when you use it in the client, you don't really want to write like new object 1, new class 1 and new class 2, new class 3. You don't want to instantiate one by one. You just want to do it all at once. So that now what you will do is you will wrap all of those functionalities that you want in a single function, and that single function or an object you will be using in the client side. That is how the Facade pattern works. So one analogy of this pattern is having a smartphone and you have to type the number you want to call. So instead of calling the number by typing it, you use quick actions to obtain a number from a list, and you call the number when you tap on the quick action button. You can still manually enter the numbers, but the UI Facade can carry out this process for you in one go. Alright. Now let's see the UML diagram for it. This is the UML diagram. So here what happens is, as you can see, this is the Facade, this is the service A interface, this is service B interface, this is implemented by this is implemented by this. Now you want to use both of these. Okay, you want to use service A as well, you want to use service B as well. Let's say there is a task and the task got cancelled or blocked. So what you will do is all the assignees to that task will also get updated so that this task is not assigned to those, and the number of tasks assigned to the assignees will eventually decrease as well. So there are two things happening. Will you call multiple APIs from the client side? One code for updating the task, one for updating the assignees, and if any other operation is going on and you do that also, that will create a mess up of a code. So instead you create a Facade that has both these services, and then you have perform method so that where you utilize the both and then make the code readable. Now we shall see how to implement this pattern using Typescript. Alright, so here we are and we will be implementing our Facade pattern using Typescript. So I have defined two interfaces. Interface, let's say batsman, and here it will be like play shot, and yeah, this will return nothing. Interface bowler, bowl, void. So two different functionalities. Now we shall implement this. Let's say class opening batsman implements batsman, and we will implement this let's say he hits it out of the park for 6 runs. So the batsman hit the ball for the 6. If you know about cricket, you must know. Anyway, let's create the second object for the bowler. Class bowler, oh, sorry, opening bowler. Implements bowler. Right. Console log. Here what will happen is bowling. The first delivery of the match and the batsman is out for a golden duck. Alright. Now you have two objects. See carefully. You have two objects. Opening batsman, opening bowler, implementing two different interfaces. But you know that there can be an all-rounder as well. If you watch a cricket match, you know that there is an all-rounder who does bowling and batting both. Like Hardik Pandya, Andrew Flintoff, Ian Harvey. So people like those. Now, if they can do both of the things, how can we do the same thing in programming? We want to use these two things. It is quite simple. We'll create a Facade class. Class all-rounder. This will not implement any interface though. Private batsman, private bowler, constructor, batsman, bowler, and the normal housekeeping work. Batsman equals to batsman, bowler equals to bowler. Okay, here is mistake. Now there will be a play method. Won't return anything actually, but this dot batsman dot play shot, this dot bowler dot bowl, and that's it. That's actually it. Now the client will use it const all-rounder, or let's say underscore iteratively all-rounder equals to new all-rounder, here new opening batsman and new opening bowler and all-rounder dot play. That's it, guys. That's completely it. This is how you implement the Facade pattern. It is very easy to implement, and this is very handy and very useful as well. So you have two interfaces, and there are two implementations of those interfaces, two different implementations. Now what you want to do is you want to use both of the functionalities. If you want to use both of the functionalities, you will not call them individually in the client side. Instead, you will create a Facade, and then you will use that Facade into this client side for more code readability. Now we will see the output of this by running the code. I will run this code from here, and boom! He hit set out of the park for 6 runs and told him the first delivery of the match and the batsman is out for a golden duck. So this means that our code is working fine. The facade pattern worked really fine here. So this is how you can implement the facade pattern using Typescript. Alright, now we shall see the interview questions. Here we are. We will see the interview questions for this. Here you can see. Can you explain the facade pattern and its use cases? So we already did that. We explained the facade pattern, the definition initially only. So what can be its use cases? So see, when you want a simplified interface and when you want to encapsulate the complexities of a subsystem, in such kind of things you can use this. Apart from that, you can also use it, just to create a wrapper to improve the code readability in your client side. Now, second question, how does the facade pattern relate to other design patterns? This can be related in several ways, like with adapter pattern. The adapter pattern used to make two incompatible interfaces work together. The facade provides simplified interface to a complex system. Both can be used together, and an adapter can be a part of the facade. Apart from a singleton pattern, so a facade class can also be implemented as a singleton. There's a need to have a single instance facade to coordinate access to the subsystem. Mediator pattern. The facade provides a high-level interface to set of objects. Mediator pattern centralizes complex communications and control among a set of objects. That is how it relates to other design patterns. In what scenarios we would use this design pattern? We may use it when we have a complex subsystem and we want to provide a simple interface to interact with it. We may want to decouple the client code from the subsystem and making the client code less dependent on subsystem's implementation. Or we want the refactoring of a legacy code and make it easier to read. Or maybe we are designing a library or a framework and want to provide clean API for the clients. Now, what are the potential drawbacks or limitations of using the facade pattern? So, the drawbacks are like this can increase the complexities. It can introduce additional layers of abstraction. This added abstraction can sometimes make the system more complex. Maybe the facade becomes insanely large so that it itself becomes difficult to read. And reduce flexibility. So since it unites all the interfaces, you cannot simply make changes. Okay, if you make changes, maybe the entire application would crash. Oversimplification. So while merging all the interfaces and then simplifying everything, this will be kind of over engineering, and maybe we will not be able to understand the underlying capabilities of the system. Performance overhead. This can add some overhead on the performance due to additional method calls and abstraction limits. And maintenance burden. So yeah, this can be difficult to maintain as well. Anyway, how does this pattern improve code maintainability? So this reduces the complexity for, if you want to have only less number of interfaces, like 3-4 interfaces, then this will be used to reduce the complexity. Recently we saw in drawbacks that it might increase the complexity. So that means, if you have very large number of interfaces, then it can. However, for small interfaces and small number of interfaces, this can reduce the complexity. And the changes are quite centralized, so changes to a subsystem can be made behind the facade without affecting client code. Just by encapsulation, since it keeps the client code decoupled from the subsystem. And improved readability, so this makes the code more readable by providing clear and simple interface. Alright, So that's it from this video. We studied about the facade pattern uses, criticisms, into questions in implementation and UML diagram and all. In the next video, we will study about the composite pattern. Until then, bye.